Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome to my video on chords, and no, we're not talking about the chord you use to plug in your phone. We're talking about a geometric chord. So I'm going to rough sketch this so I don't have a really big circle. So here's a circle. We've got to have a point in the middle of it, right? And normally we draw like a radius or a diameter or something like that. Well, a chord is any segment who has endpoints on the circle. So AB happens to be a chord. So line segment whose endpoints are on the circle. Now we're all familiar with one particular chord, and that happens to be the diameter. A diameter is just an example of a chord. Chords do not have to pass through the center, so keep that in mind. All right, so I'm actually going to draw some circles here. Actually, I'm going to rough sketch some circles. I have graph paper here for this purpose. That's the only reason why is to rough sketch them. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, rough sketch. Takes a little less time. Okay, so if I were to draw where this is W and this is X. And this is Y and this is Z. Okay, so I have two triangles going on here. If XW is congruent to YZ, XW is congruent to YZ, then what can we say? Well, this is a radius, this is a radius, this is a radius, this is a radius. So by side, side, side congruency, we know these two triangles are the same size. So because of that, we also know that since the triangles are congruent, the corresponding parts of the congruent triangles, so we can say the measure of angle XPW, that one, is congruent to the measure of angle YPZ, this one. Which makes sense because there's the radius making up the sides and all that good stuff. So one, two, three, 1, 2, 3, 1, 2, 3. Rough circle. Graph paper makes circles a little bit better. So what about if I look at this and this? And I'm going to call this J, this K, this L, and this M. Okay. So if arc JK is congruent to arc LM. So I'm saying this is the same size as this. Remember, technically, We have the radiuses here. So technically the triangles are congruent because here's the thing. Whatever this arc is, the angle matches. Whatever this arc is, the angle matches. So we'd have side, angle, side. And so if the arcs are the same, we can also say these JK and LM are the same because of side, angle, side with that congruent. So JK is congruent to LM. So not only is the arc congruent, that line segment connecting them is congruent. So everything goes back to those related triangles. But the nice thing is anytime you draw a triangle that uses a radius of the circle, if none of the lines are extending, you have an isosceles triangle, which kind of makes it neat. Okay, so let's draw a little bit different image this time. Okay. Little lopsided, right? Okay, we're gonna put R as the middle of this one. And I'm gonna have AB right here. And CD is gonna be right here. And then there's a perpendicular line. Whoops. That's what you get for eyeballing, perpendicular. There we go, perpendicular line. And we're going to call this F and this E. So what about if R, not P, yeah, I meant to call that an R. RF is congruent to RE. Okay. What does that tell us about AB and CD? Well, let's keep some things in mind. Let's look at this right here. Could I draw a right triangle? I absolutely could. And since the hypotenuse is the radius, my hypotenuse would match my hypotenuse. Would match my hypotenuse. Would match my hypotenuse. Okay, and then by hypotenuse leg, this would be congruent to this. Also by hypotenuse leg, because they share a hypotenuse, they share a leg, this would be congruent to this. So all four of these little segments are congruent, making CD and AB both congruent. So that's another way to look at it. Okay. By the way, RE and EF is the shortest distance to that chord. It's a perpendicular bisector. So that's your perpendicular bisector is the shortest distance to a chord. So what are we doing with this? Okay, we're getting there, I promise. There's a lot of information. We'll make this a better circle. All right, here's my circle key. Okay, I am going to draw a random chord. What happens if I draw its perpendicular bisector? Okay, So perpendicular bisector, right? If you construct the perpendicular bisector to a chord, it will make a diameter every single time. You can actually find the center of your circle that way. If you don't know where the center of the circle is, you can draw a chord, do its perpendicular bisector, do that a couple times, and you will find the center because they'll all meet up at the center. So that's kind of a cool thing if you're trying to find the center of a circle. Maybe you're working at a lathe table or a plasma cutter or who knows what. You might need to find the center of a circle for some random spot. So that's a cool little trick to do that. Some of you are going, I don't want to do anything with geometry for the rest of my life. Who wants to cut out circles? Well, it happens. All right, so we are going to draw a picture. So I'm going to go ahead and pause the video. I'm going to get all the letters on here so you don't have to watch it draw it. Then you can pause and catch up as needed. Okay, so here we go. Here's what we're seeing here. And our goal is going to be to calculate GJ. So that would be here to here. Okay. Well, what is the radius of the circle? Notice the radius of the circle is right there. So that would be 13.5 feet is the radius. So that can be helpful. But what I'm seeing is that HJ plus JD equals HD, which would be the radius, right? H to D is a radius, so it'd be that 13.5. And we know J to D is 6, but we don't know H to J. So subtract 6, we find out HJ is 7.5. Okay, it's part way to GJ because we need to do GH plus HJ, and we just found out HJ was 7.5. So if only we could figure out GH. Well, because these are the same size, and it's a chord, right? The perpendicular bisector, bisector, and definitely, yep, it's a bisector, so it's perpendicular because this is a diameter. That tells us we have a right triangle. And we can do leg squared plus leg squared equals hypotenuse squared. Okay, so you can go ahead and solve that and you'll find out that x is approximately 10.06. So when we put that 10.06 together with that 7.5, we find out that GJ is approximately 17.56. So just knowing the little relationships in chords can help us out, and drawing circles and knowing that they're there is a big deal too. All right, so we're gonna do some quick fun constructing some pictures because why not? The first thing you're gonna do is you're going to pick up a compass, any compass. Okay, put a point on your paper. I don't care how big it is, just draw a circle. All right. Now, keeping this here, you're just going to put a point anywhere on here. Just put it down, I don't care where. And you're going to draw a circle, but only the part that goes inside your original circle. So start at the edge. This should go through your vertex or through your center of your circle. Okay, now wherever it ended, I want you to put your pointy part and repeat. So I find it easier to move the paper. Wherever you ended, that's your new pointy part. Repeat. Wherever you ended, that's your new pointy part. Repeat. It's your new pointy part. Repeat. And one more time. When you're done, if you haven't made yourself dizzy by watching my paper, you should have a little daisy. Okay, now, if I put a point at the tip of each petal, and I connect them with chords. So by drawing this flower first, and yes, I'm calling it a flower. Some of you may have thought of something look like an advertisement for something. We're going to call it a flower. We actually have a perfectly drawn hexagon. And if you were connecting all the vertices, you would have equilateral triangles inside your hexagon. So that's one way that we can actually use a circle and an arc to start making regular shapes. So all these are congruent segments. We could draw congruent triangles that way. So don't shy away from your compass just because it's with geometry. You can do really neat artsy things with it as well.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.